Okay, so let's see a question regarding queue. So dry run and execute the following pseudocode segment. So we got a queue here, and then there's a loop that's going on. It's a for loop from 1 to 14. Right, so starts at 1 and goes up to I less than 15, which is 14, right? And I plus plus, so it just increments by 1. So let's look at, let's run from 1 to 14 now. So the first thing is we need to create a queue, right? I'll just represent the queue here like that. So when I is equal to 1, so 1 mod 3 is basically 1, that is not equal to 0, which means we are enqueuing 1, right? And then it goes here, I becomes 2, 2 less than 15 is true, and then 2 mod 3 is 2, that is not equal to 0, which is another enqueue, so 2 comes here. Now i's value becomes 3, right? And 3 less than 15 is true, it comes here. 3 mod 3 is 0, right? So because of that, this is false. It comes to the else part and does a dequeue. So when you hit 3, it basically dequeues 1, right? And then I becomes 4, right? 4 less than 15 is true, 4 mod 3 is 1, 1 is not equal to 0, because of that it will enqueue, so 4 enqueues. Now I becomes 5, 5 less than 15 true, 5 mod 3 is 2, that is not equal to 0, so enqueue again 5, right? And then I plus plus, I becomes 6, 6 less than 15 true, 6 mod 3 is 0, that is this guy becomes false, this condition, it comes to else and dequeue, right? So when you hit 6, it is a dequeue again. So when it is 7, it is an enqueue. When it is 8, another enqueue. When you hit 9, which is like mod remainder of 3 is 0, right? So basically 3, 6, 9, they all make this dequeue, right? So again 12, 13, and it will go up to 14, right? So here 12 also, it's a similar thing. So 7, 8, when you get 9, you have to dequeue, and then 10, 11, when you get 12, you got to dequeue, and then you have 13 and 14, right? So this should be the last answer. So 7, 8, 10, 11, 13. So this guy. No, not that guy. It should be this guy, right? Okay, we'll move on to the second question. So consider the following statements. A stack is a list. Stack is a list with restriction that items are inserted or removed, that means deleted, only at one position. It's a list where items are removed from one, added or removed from one position, namely the end of the list. So if you remove items from insert at the end and remove from the end, so that is last in first out, right? So that is a stack, right? The general model is that one where there is some element that is at the top of the stack. Yes, there's some element at the top of the stack, and it is the only element that is visible. Yes. So when you talk about a stack, the only element that is visible is the top of the stack item. So that is also correct. So this is correct, this is correct. A pop or top on an empty stack is generally considered an error in the stack abstract data type. Yes, so you can't do a pop or a top on the empty stack, right? So that is considered wrong, or an error, right? Okay, so the fourth one, the fundamental operations on stacks are push and pop. Okay, yes, where push is relevant to the removal. Oh, push is relevant to the removal. That is wrong. Push is relevant to addition or insertion, and this further says recently inserted element, and pop is equivalent to an insertion. Basically, it's the other way around. Pop is actually removal, right? And push is insertion, right? So because of that, this is wrong. A stack is a list. Insertion and deletion can be performed from both ends. No, in a list, in a stack, you can perform insertion and deletion at only one end, right? So this is also wrong. So it should be 1, 2, 3. Which of the above statements are valid for stacks? So it should be 1, 2, and 3. So this guy. All right. Consider the Java program segment given below. Public void data structure. Okay. So you are passing in an object X. It checks for empty. If it is empty, the back front, there's a new list node that is appended, like assigned to front as well as back. If it is empty, or else the back.next is a new node, and the new back is back.next. So basically there's something. So let's say there's something at the end, and this is the new node that is coming in, which is X, right? So this was the back. Okay, so back.next is now X, and then back becomes back.next. So this guy literally points to this one now. So this is what happens here, right? So which of the following describes the activities of the above Java program? Select one or more. If the queue is not empty, so not empty means you are talking about the else part. The new element is added to the back end of the queue. Yeah, that's correct. If the queue is not empty, the new element is added to the front end of the queue. No, that is wrong. It's not added to the front, it's added to the back. If the queue is empty, so it's this condition, empty condition, then it will make a queue of one element. Yeah, basically it is making a queue of one element, so that's correct. If the stack is not empty, so not empty is this else part, the new element is added to the back end of the queue. So it's not a stack here. It is basically we are talking about back, right? So that's a queue. So this is wrong. If the stack is empty, that is it's a queue. So it's wrong. So here we have 2. This is 1. This is 1. Okay, A and C. Okay. Consider the queue of the characters where it is a straight queue. It is a straight queue which is allocated 8 characters, right? Okay, so for 2, front is 2, rear is 5. Okay, we have a queue here, right? So let's say we have a queue here. A, B, C, 1, 2, 3, right? Okay, so that is 2, rear is 5. Okay. All right. The following operations have to be performed. Right? D is added to the queue. 2 character. Okay, you have some operations here. What are the intermediate correct front and rear values when the above operations are performed? Okay, so when you add D is added to the queue means D comes here, rear will go here, right? So that's 6. So 2, 6, front is 2, rear is 6. So we have one here like that. That one should be correct. Okay. 2 characters are deleted from the queue. So two characters are deleted means now you have the front here. So you get rid of this. So this arrow goes here, right? Front. So this is front now. So this is basically 2, 3, 4. Front is 4 and 6. Okay. So that's that. It's correct. E and F are added to the queue. So adding E and F. So rear is now 6. So rear will become R plus 2, which is 8. Right? So front remain 4. And rear will be 8, right? So probably, I'm not sure whether this should be 7. So 4 and 8 we don't have, and then so this is, you don't have that state. 1 character is deleted from the queue. 1 character is deleted from you. So now it becomes, the front becomes 5 now, right? It was previously 4, now it's 5, right? Deleting means it's dequeuing. So now, so there's F5 and 8. So it should be this. G and H are added to the queue. So G and H are added to the queue means now it's the rear. Right? Adding means you are basically wrapping around. Right? Wrapping around means it's now 8 becomes, so it would go to G goes to here and H goes to here. Right? So it is, so now rear is 1, right? So front is 5, rear is 1. So that is the last condition. So these 3 are correct, right? All right, so that's about it for this discussion. We'll talk about some other questions on another session. Okay, thank you very much.